All right, we're doing the product rule now. X cubed times 2x plus 3. And I'm going to do the first lot of these really structured. I'm going to write u, v, u dash, v dash. Now, when I say dash, that's derivative. Technically, I should be saying u prime, but so u is going to be x cubed, so u prime is 3x squared, v 2x plus 3, so v dash is 2. So you can see that I've taken each of these and I've derived them. Now, the rule is if like f of x is u times v, then f dash x is going to be the first times the derivative of the second plus the second times the derivative of the first. And this can be written so many different ways. But this is how I like to write it. It's just clean, it's quick. So I've got x cubed times the derivative of the second, which is 2, plus 2x plus 3 times the derivative of the first, which is 3x squared. Which means I've got 2x cubed plus 3x squared times 2x plus 3. I don't believe it wants us, this is 8.6. Yes, it looks like it wants us to expand. So I'm just checking out the answers in the back of the book. So 2x cubed, or at the end of the PDF, plus 3x squared times 2x is 6x cubed, 9x squared, which means I've got 8x cubed plus 9x squared. Question 2. We've got 3x take 2, 2x plus 1. So I'm going to let u equal 3x take 2, v's 2x plus 1. So u dash is 3, v dash is 2, which means I've got 3x take 2 times 2 plus 2x plus 1 times 3. Now it looks like they do want us to expand these, so that's going to give me 6x take 4 plus 6x plus 3 gives me 12x take 1. Let me double check. Yep, they definitely want us to expand. Okay. Question 3. We've got 3x times 5x plus 7. So u is going to be 3x, u dash is 3, v 5x plus 7, v dash is 5. Which means I've got 3x times 5 plus 5x plus 7 times 3. If you really set yourself up by doing like these lines every time and doing it the same every time and writing it out properly each time, you'll really get into a good habit where this will become automatic and you won't have to stress when you're doing these questions. 15x plus 15x plus 21, 30x plus 21. And question 4, we've got 4x to the 4 times 3x squared take 1. So u is 4x to the 4, u dash 16x cubed, v 3x squared take 1, v dash 6x, which means I'm going to have 4x to the 4 times 6x plus 3x squared take 1 times 16x cubed. Gives me 24x to the 5 plus 16 times 3, 48. 48x to the 5 take 16x cubed gives me 72x to the 5 take 16x cubed. All right, question 5. So we've got 2x times 3x to the 4 take x, which which means u is 2x, u dash is 2, v is 3x to the 4 take x. Why did I put the bracket there? I don't know. V dash is going to be 12x cubed take 1. So I've got 2x times 12x cubed take 1 plus 3x to the 4 take x times 2. That gives me 24x to the 4 take 2x plus 6x to the 4 take 2x gives me 30x to the 4 take 4x. Question 6. We've got x squared times x plus 1 cubed. U dash, v dash. U is going to be x squared, 2x. X plus 1 cubed gives me 3 lots of x plus 1 squared. I won't expand that. So I've got x squared times 3 lots of x plus 1 squared plus x plus 1 cubed times 2x. I'm looking at the answers just to see how far they want me to expand this. This means I've got, yeah, they want me to go a long way. So we've got 3x squared, lots of x plus 1 squared, plus 2x, lots of x plus 1 cubed. Now if I take x plus 1, if I take x times x plus 1 squared out, then I'm left with 3 plus 2x plus 1, which means I've got x times x plus 1 squared times 3 plus 2x plus 2, so 2x plus 5. Is that where that's it? They got 5x plus 2. How did what did I do? Oh, it should have been 3x. That makes sense. 5x plus 2. Okay, and 7. Where are we? These lines are a bit more of a slog than the others. 4x times 3x take 2 to the 5. U dash, v dash, 4x 4, 3x take 2 to the 5 gives me 5 lots. 3x take 2 to the 4 times the derivative of the inside, which is 3, which is 15. 3x take 2 to the 4, which means when I then use the product rule, I've got 4x times 15, 3x take 2 to the 4 plus 3x take 2 to the 5 times 4. I'm going to take 3x take 2 to the 4 out. I'm going to be left with 15x plus 3x take 2. Gives me 3x take 2 to the 4, 18x take 2. So I can take 2 out again, so that's 8, 3x take 2 to the 4, 9x take 1. Excellent. Okay. That's 7. All right, let's do 8. We've got 3x to the 4, 4 take x cubed. U dash, v, no, not v dash, just v dash. 3x to the 4, 12x cubed. 4 take x to the 3. We're going to end up with 3, 4 take x squared times the derivative of the inside, which is negative 1. So we're going to have 3x to the 4 times negative 3, 4 take x squared plus 4 take x cubed cubed times 12x cubed. So what goes into both of those? 3x cubed times 4 take x squared. Okay. From this left lot, I've got negative 3x. From this right lot, I've got 4 times 4 take x. So I've got 3x cubed, 4 take x squared. Negative 3x plus 4 take 4x, so I've got 16 take 7x. And if I made that a nice square round bracket, then I am done. Okay, question 9. We're just getting more complicated versions of the same thing, really. X plus 1 to x plus 5 to the 4. U dash, v dash. X plus 1, 1. 2x plus 5 to the 4 means I've got 4 lots of 2x plus 5 to the 3 times the derivative of the inside, which is 2. 8 lots of 2x plus 5 to the 3. Okay, so we've got x plus 1 times 8 2x plus 5 to the 3 plus 2x plus 5 to the 4 times 1. So I'm going to take 2x plus 5 to the 3 out, and I've got 8 lots of x plus 1 plus 2x plus 5 times 1. So I've got 2x plus 5 to the 3 times 8x plus 8 plus 2x plus 5, 10x plus 13. Okay, question 10. We're almost halfway. So we've got x cubed plus 5x squared take 3, x squared plus 1 to the 5. U dash, v dash. X cubed plus 5x squared take 3, 3x squared plus 10x. X squared plus 1 to the 5, that's a 5. 5 lots of x squared plus 1 to the 4 times the derivative of the inside, which is 2x. So I've got 10x, x squared plus 1 to the 4. So when I come to derive it, I've got x cubed plus 5x squared take 3 times 10x x squared plus 1 to the 4 plus x squared plus 1 to the 5 times 3x squared plus 10x. So what goes into both of those? Well, obviously I've got x squared plus 1 to the 4, and I can also take x out. Okay, from this first lot, we're left with 10 lots of x cubed plus 5x squared take 3. From the second lot, we're left with 3x plus 10. We've also got that x squared plus 1, because that was to the 5 and I only took to the 4 out. So that's x squared plus 1 to the 4. Yeah, I'm going to do this. 10x cubed plus 50x squared take 30 plus 3x cubed plus 3x plus 10x squared plus 10. So I've got x squared plus 1 to the 4. 13x cubed plus 60x squared plus 3x take 20. It's as easy as that. Question 11. Oh, why are they even... okay. They're just making it hard. You'll never see something as annoying as this in the HSC. unless it was like a multiple choice and they wanted you to eliminate stuff quickly. 3x squared plus 2, because it's just annoying, this question. It's not, we can prove that we know the concept and understand it on questions that require a lot less annoying manipulation. So we've got 3x squared plus 2x, take 1, 6x plus 2. 2x squared plus 5x, take 2 squared. 2 lots of 2x squared plus 5x, take 2, times the root of the inside side, 4x plus 5. Okay, so we've got 3x squared plus 2x, take 1, times 2 lots of 2x squared plus 5x, take 2, times 4x plus 5, plus 6x plus 2, 2x squared plus 5x, take 2 squared. I'm not going to bother with the rest. It's just annoying manipulation. All right, 12. Okay, this is somewhat nicer. 4x cubed, 2x, take 1 to the negative 3. So u dash, v dash. So we've got 4x cubed, 12x squared. 2x, take 1 to the negative 3 gives us negative 3 outside of 2x, take 1 to the negative 4 times the derivative of the inside, which is 2, which is negative 6. 2x, take 1 to the negative 4. So we're going to end up with 4x cubed times negative 6, 2x, take 1 to the negative 4, plus 2x, take 1 to the negative 3 times 12x squared. Honestly, to save yourself some time, I would skip the really annoying working out with these. No, actually, I'm going to do it because the negatives confuse us a little bit. Okay. So what's going to appear in both of these? Actually, no, I'm going to write them properly. Negative 24x cubed on 2x, take 1 to the 4, plus 12x squared on 2x, take 1 cubed. Now that's going to give us, let's take the 12x squared on 2x, take 1 cubed outside of it. For this first one, we're left with negative 2x on 2x, take 1. Second one, we've got plus 1. And we can leave it like that, I believe. What question is this? 12. Oh, they left it. They didn't even bother with that second step. Okay, 13. See, I should have just done what I said. 5x plus 4 cubed, x plus 1 to the 4, u dash, v dash. By now, you really should not be having to write u dash, v dash. Maybe v dash. Sometimes, okay. Do this. So we've got 5x plus 4 cubed. We're going to have 3 times 5x plus 4 squared, but we're going to have to times it by 5. So we're going to have 15. X plus 1 to the 4, 4 lots of x plus 1 cubed. So we've got 5x plus 4 cubed times 4x plus 1 cubed, take, plus x plus 1 to the 4 times 15, 5x plus 4 squared. Common factors, okay, we've got 5x plus 4 squared, we've got x plus 1 cubed, we're left with 4 lots of 5x plus 4, and we're left with 15 lots of x plus 1, 5x plus 4 squared, x plus 1 cubed, 20x plus 16 plus 15x plus 15. We've got 20 plus 15 is 35x, 16 plus 15, 31. And question 14. Again, just an annoying working out question. 2x squared plus x take 7 to the 5, 3x take 4 to the 7, u dash, v dash. So we've got 2x squared plus x takes 7 to the 5. So we've got 5 lots of 2x squared plus x takes 7 to the 4 times 4x plus 1. V, 3x take 4 to the 7. So we've got 7 lots of, well, we're going to end up timesing it by 3, the 3 inside. So we've got 21, 3x take 4 to the 6. Okay, so we've got 2x squared plus x takes 7 to the 5 times 21, 3x take 4 to the 6 plus 3x take 4 to the 7 times 5, 2x squared plus x takes 7 times 4x plus 1. And I'm going to leave it there. Who could bother doing that? 15. Okay, now they're getting a bit more actually interesting. So we've got 2x, x plus 3 to the half. So that's the square root of that. U dash, v dash. 2x, 2. Now this is x plus 3 to the half, which means we've got a half, x plus 3 to the negative a half. Which is the same as 1 on 2 root x plus 3. So we're going to have 2x times 1 on 2 root x plus 3 plus root x plus 3 times 2. On the left-hand side, those 2's cancel out, so we've got x over root x plus 3. On the right, we've just got 2 root x plus 3. That's just over 1, which means common denominator, cross multiply, we've got 2x plus 2, root x plus 3 times root x plus 3. And this whole thing's on root x plus 3, which means we've got 2x plus 2, lots of just x plus 3. Which means we've got 4x plus 6 over root x plus 3. It's funny how that came out so nicely. I like it when they do that. What question was that? 15. Oh, they left it, they kept it off. Okay. I thought I was being fancy with the surds. 16. You didn't have to be fancy with the surds. We've got 5x plus 3 to the 4 times x takes 7 to the negative a half. U prime, v prime. So we've got 5x plus 3 to the 4 is going to become 25x plus 3 cubed. X takes 7 to the negative a half, becomes negative a half, x takes 7 to the negative 3 on 2. So all up, that's going to become 5x plus 3 to the 4 times negative a half, x takes 7 to the negative 3 on 2, plus x takes 7 to the negative a half times 20, 5x plus 3 cubed. I'm not going further with that. I mean, I would if it was asking me to show that it came out as something, but no, not for this. that's, okay, 17. So we've got x times, now root 2 take x is 2 take x to the half. So u dash, v dash, x1, 2 take x to the half becomes negative a half, because, yeah, it's a half at the front, and then negative because the derivative of the inside is the negative. 2 take x to the negative a half. So we've got x times negative a half. This is the same as negative 1 on 2 root 2 take x plus root 2 take x times 1. So I'm going to have negative 1 on negative x on 2 root 2 take x plus root 2 take x. And if they went any further with that, they're out of luck. 18. We're so close to being done. We've got 2x plus 9 root x squared take 4. So u dash v dash 2x plus 9, 2 x squared take 4 to the half, half x squared take 4 to the negative half times 2x gives us x on 2 root x squared take 4. So we've got 2x plus 9 times x on 2 root x squared take 4 plus root x squared take 4 times 2. And I'm not going any further with that. 19, 8x plus 1 cubed times the cubed root of 9 take x cubed. U dash v dash. So we've got 8x plus 1 cubed. We're going to have 3 times 8, 24, 8x plus 1 squared. This is 9 take x cubed to the half. So we're going to have half 9 take x cubed to the negative half times negative 3x squared. So that's negative 3 on 2 root 9 take x cubed. Okay, so we've got 8x plus 1 to the 3 times negative 3 on 2 root 9 take x cubed plus root 9 take x cubed times 24 8x plus 1 squared. Again, not going any further with that. Last but not least, 20. Now, we've got x on 4x plus 5 to the 7, which is the same as x times 4x plus 5 to the negative 7. U dash v dash x and 1, lovely. 4x plus 5 to the negative 7 becomes negative 28. 4x plus 5 to the negative 8. So we've got negative 28x on 4x plus 5 to the 8 plus 1 on 4x plus 5 to the 7. And that's all she wrote.